In today's HVAC training video, we have my friend Tyler from the Sauermann group doing a training on combustion analysis, and what I really like about Tyler is that he can communicate complex details in a way that just anybody can understand. So I hope you enjoy this video.
What are we going to go over today? We're going to go over a whole host of things. I'm going to kind of breeze through this here and not in any kind of specific order. We're going to go over why you're here. Now, I know your parents have always told you why you're here, and I think it's a very sweet and eloquent story. My version for you is going to be a little bit different because I have a different level of appreciation for who you are and what you do in the industry. We're going to go over cross-contamination verification with an analyzer, how to make money with an analyzer, CO safety, commissioning, diagnostics, and maintenance attributes of an analyzer. We're going to go through how to test, why to test, what some of the readings mean, cracked heat exchanger verification. And I think you're going to find that an analyzer for you is going to do one of two things, or one of two primary things. It's either going to give you a neon sign that says you must repair or replace this, or it's going to give you a series of breadcrumbs that it's going to lay out in front of you that will lead you to the appropriate or necessary repair. And hopefully by the time that we're done, you're going to find that there's a lot of tentacles to this tool and maybe some aspects of it about it that you maybe were not aware of before. And if you've been using one for a while, hopefully give you some additional insight into how you can use it more effectively. But before we do, keep your side of the street clean, as Chuck Norris is giving you the thumbs up here. You cannot control what happened before you got to that job site. You cannot control what happens after you leave that site. But you sure as heck can control what happens while you're there, which means to do your testing. And you're going to hear me speak about liability sprinkled in through the rest of this presentation here today. I don't want you to be scared or overly concerned. If you are doing your job and doing it effectively, you don't have to worry about it. What I'm trying to prevent is you from being concerned or scared of things hunting you down after the fact. If you do your job effectively while you're there, you're not going to have to worry about it. So again, keep your side of the street clean. If you do, you'll show optimum effectiveness with all this. And there is no combustion troll, even though we might like to think that there should be. So there is no nice little pointy-eared gentleman living in your system there. And as I have up here, manifold gauge set equals combustion analyzer. You know, it's interesting. When we diagnose air conditioning, and Craig will attest to this, you can't do it without a manifold gauge set. You're hooking up different probes, looking at pressures, temperatures, static pressures, everything else under the sun, looking at duct pressures for things. You're using a manifold gauge set, though, when you're diagnosing that system. You cannot effectively diagnose without it. You couldn't weigh in your charge, you couldn't charge a system without it. Well, it's the same thing with combustion. With a combustion analyzer, it does that in like fashion, but for a fuel-fired appliance. It's going to give you all the system's relevant vitals. It's going to give you pressures, such as gas pressure, static duct pressure. It's going to give you draft, which is also another pressure measurement, because there's a pressure manometer built into each one of the analyzers. It's also going to give you the vital readings, such as oxygen, CO, CO2, and it's going to do one thing additional that a manifold gauge set doesn't do. It's going to give you the efficiency of the piece of equipment. It is the fuel utilization, but it's going to give you the efficiency of that equipment, which is something I'm going to go into a little bit later on into the conversation. So if you have yet to be using an analyzer for your diagnostic, commissioning, and maintenance needs, you're going to want to start using one, God willing, after this presentation here today. And as I talk about that, another thing we do with fuel-fired equipment is we're lighting a fire in somebody's house every time we turn it on. Or if it's a building, we're lighting a fire. Don't you think it might be in our best interest to maintain it and to get a level of performance out of it and to understand what it is putting out and controlling how it's burning and how effectively and how safely it's burning? I think it is. You know, this slide here is a joke, but it says when your furnace has more pyrotechnics than a KISS concert. These kind of things happen. And these are the kind of things, especially in this one image here, that I want you to start to pay attention to, because you're going to find, as you go from job site to job site, things you're going to have to be aware of, and you're going to have that situational awareness. And it starts with things like this. As I have on here, the reasons you're here. The reason you're watching a presentation like this is that you don't do these types of things. That furnace right there in that image, the flue gases were actually piped into the supply trunk, which means it's going to poison a family. This is a rental property out in Ohio that, thank goodness, was noticed before anybody took occupancy after some re-rigging of the system took place by an unsavory contractor. But these are the kinds of things you need to pay attention to. You might have been sent there to diagnose this water heater here that has gutter leader on it for its flue piping. But over in the other corner of the basement, there could have been this furnace here that had the flue piping going into the supply trunk, okay? So as you go into job sites, you need to understand you're the expert. You could be held liable for the things on this job site here, even if you weren't sent there to look at it, because you're the expert, you're the one that's there signing off on that the equipment is working effectively, okay? So it's in your best interest to kind of open up your peripheral vision and see things around you, because not only could you save somebody's life and possibly save your own, obviously, you could also find financial or money-making opportunities for you as a contractor, that you can better your relationship with your customer and further your progress along. And some other images here. We see here very shoddy craftsmanship on running our intake and our exhaust. And then while we're at it, we're cutting holes in doors to run our condensate. This is the kind of shoddy workmanship that if you inherit this kind of problem, you need to let that customer know, listen, this is not how it should be done. I don't want to disrespect anybody that walked before me and did it here, but this is not how this should be done. We need to have this corrected. And over here too, you're going to notice this transition here of this horrible flue piping. This should not be taking place. We have people in our industry out there doing work, not pulling the necessary permits and not doing their jobs effectively, okay? We need to level up our industry. You know, the old expression, a rising tide or a rising tide levels or raises all boats. That's what we're trying to do here. We're trying to raise all boats by our education. Hence is the reason that Craig had me do this presentation for everybody today, because it's important, okay? We want to pay it forward. People like Craig, who's been doing it for a very long time and at a very high level, as you all know, he is paying it forward. He's doing this because he wants to educate the industry. He appreciates all of you, and that's why he's doing it, and that's why we're trying to do it as well. And more. You see over here on this furnace with this flue piping here, that's a supply register that was cut into the exhaust. The homeowner's comment to the technician that went after the fact and noticed this was, I was adding heat to the basement for the kids so they're not cold this coming winter. Well, that's the kind of thing where the kids go down for a nap during the heating season and they never wake up, because he would have piped the CO and all the other flue properties into that space. It would have potentially killed his family and killed them and killed themselves. Okay, all with the best intentions. This is another reason why people should be hiring a proper contractor like the ones that are watching this. You want to hire a proper contractor to do the right job for you. But when they do that, and if you're said contractor, it is up to you to do your job correctly. And then you're going to see things like this over here too, with this shoddy workmanship with this flue piping. So these are just some things you need to notice to have situational awareness, and that is why I bring it up. So what do we have? Why we are here, revolution and evolution. Well, the revolution side of this is on the side of equipment manufacturers. Equipment that we return in our industry to a manufacturer that we think is defective is returned at the rate in our country, in the United States, at the rate of 25 to 35%. That is exceedingly high. Why is that? Well, let's take a look at the greater picture first before we get into why that is. If you compare and contrast that to Europe and the rest of the world, so to speak, especially over in Europe, their return rate for equipment is only 3 to 4%. Why? That is because combustion analysis is mandatory in those countries. They have to do it a minimum usually of once per year, sometimes twice per year. Okay? They have to use it for its commissioning purposes, its maintenance purposes, and its diagnostic purposes every time they engage a fuel-fired appliance. And why do they do all this? They do all this because those countries predominantly get their fuel from Russia. It's very expensive. If they did not control all the different combustion processes taking place, their economies of scale would slowly crumble and implode on themselves. That's why you see a lot of diesel fuel over in those countries. That's why you see a lot of smaller vehicles over in those countries. You don't see big, humongous SUVs there. Everything is smaller because they want to leave a smaller carbon footprint because financially it is in their best interest outside of environmentally. So what's been happening, though, is that success leaves clues, and the manufacturers realize this. And when they dissected all this data, they've learned that something very magical happens when you commission a piece of equipment correctly, when you maintain it like you're supposed to, and when you diagnose it using an analyzer correctly. By those three touches, that has significantly driven down the amount of warranty claims. I was just at the Eastern Energy Expo in Atlantic City speaking there a couple of weeks ago. And one of the challenges with the equipment manufacturers there, they were complaining about how many condensing systems come back that the mechanics or the contractors think are defective. And they're realizing it's an oxygen issue. And we have cross-contamination issues, which I'm going to get into when we go over some of the uses of an analyzer later. And I'm going to go over tips and tricks on how, not tips and tricks, but tips on how to alleviate that from the equation so that you know your equipment is installed correctly every time, okay? So again, manufacturers realize that success leaves clues. They realize that they can't make it a government mandate in our country, but what they can start to do, like they're doing here, is put it in their manuals. We have here, combustion measurements will be made at this point. They're putting it in their manuals because they want you to test. In addition to that, we have some municipalities around the country that are also making it mandatory for you to do combustion analysis. They're making it mandatory in order for you to qualify for final payment and final inspection that you submit the combustion analysis to them. It's in certain pockets of the country, outside of Colorado Springs are doing it, and I'll get to a story about that in a second, but it's working its way around slowly, so it's just something to be cognizant of. So between the revolution on the side of the manufacturers and on the side of the municipalities, it has elicited an evolution in the way that we practice. This is no longer business as usual. We have to, again, take a different approach, level our performance up, and do our job effectively, which means using an analyzer. And again here, manufacturer's example. This is a lock-and-var boiler, simple in the manual, giving you targets for high fire and low fire, targets for CO2 and O2, okay? They're putting it there because they want you to test. And we also know that there are certain manufacturers that are starting to make it mandatory for your customer to qualify for warranty. You have to submit the combustion analysis to them. And if you don't submit it, that customer does not qualify. So that is starting to make its way around too. And I know the bigger manufacturers are looking into doing it as well. Venting. Let's talk about PVC for a second, our beloved polyvinyl chloride. For those of you that are not aware, PVC as a means of exhaust venting in our industry is slowly going away. We were using or have been using PVC for purposes it was never intended to be used for. It was never intended to be used for exhaust venting. Its sole purpose or primary purpose is for condensate routing. If you cut into PVC that is used for condensate routing, it has a nice rigid, crisp feel that feels just like PVC should. If you cut into PVC that is used for exhaust purposes 3, 4, 5 years into its life cycle, it's brittle, it can crack, and it can splinter, and that could be an issue. And we used to think that it was the temperature tolerances going through it, or the temperatures going through it that caused the disfigurement and for it to kind of be contorted. That is not necessarily the case. It's only 20% of it. The other 80% of that is the actual flue gases passing through it. The carbonic acid and all the other flue gases passing through it is drying out the chloride in that polyvinyl chloride makeup. It's drying it from the inside out, making it rot and making it dysfunctional, and then comprised of the fact that we have the temperatures going through it, that is causing the issue that we have today. And then you add into the fact that we have the collars that we're gluing together with PVC glue. Have you ever looked at the instructions on your PVC glue, everybody? Normally it tells you 12 to 18 hours to cure. Show of hands, and mine's not going to go up. Show of hands, and don't raise your hand, because if you raise your hand in your living room while you're watching this, your family's going to think you're crazy. But anyway, joking aside, we're not doing that. The job profitability is not built into you waiting or going back the second day to turn that system on. We also have some contractors that are forgetting to glue the connections. There was a family outside of Colorado Springs, Colorado. The whole family was poisoned, and the father of the family was actually, or is actually, permanently neurologically impaired, because this office was adjacent to a furnace that was put in, and the technicians never glued the PVC connections. And he worked there for 3 months and started to have a loss or severe loss in his neural capabilities and his cognition. Family wound up taking him to the doctor. He's now on a permanent disability. They wound up suing the contractor, suing the township, and suing all the inspectors. So now that specific town in Colorado Springs, right outside of that area, now requires you to submit a combustion analysis every time you either replace or install fresh and new any fuel-fired appliance. So it's coming, okay? And that's something that we never want to have happen. So what's happening in lieu of that is now we have polypropylene piping that has come into play. Companies like Centrotherm and Duravent are two of the leading manufacturers of polypropylene piping. They are making it that will withstand the temperature tolerances we're going to put it through. Not only that, it is not going to absorb any of the gases passing through it, so it's not going to deteriorate over time or dry out or crack or rot. And they have gasketed fittings, so there's no longer any need for PVC glue, okay? So that is something interesting in the industry. So if you're not aware of it, it's coming. State of Massachusetts, as of August 31st of 2021, no more PVC used for exhaust venting. If it's encountered, it's a red tag situation. It's been that way in the fire bureaus of New York for years, parts of California and parts of Utah. So it is working its way around. So if you were not aware of this, something you might want to be aware of now is to switch to the polypropylene piping. And if you're looking to go to jail for manslaughter, this is the way to do it. All kidding aside, you never want to do this. This is why there is a training void in our industry. You know, we've been shown a lot of things in this industry, but we haven't necessarily been taught a lot of things. And hopefully, by doing this today and having some instruction, we're going to learn a little bit more and all the other classes you're going to go to. And that is why, when I mention classes, a lot of the classes you're going to take at an equipment manufacturer is going to cover some semblance of venting. Remember when I just said, when I was at the expo a couple weeks ago, they were talking about oxygen issues coming back to systems. That's part of the training void. So now these manufacturers are looking to bolster how they train on how their equipment is installed and maintained and diagnosed, okay? But again, this is not what we do. We do not run the intake and the exhaust into the same conduit. This is not a concentric package, folks. This is improper venting done by a technician that did not know what he or she was doing. So we do not want to do that. So what is combustion? Well, before I get into what it is, here is how I want you to perceive it. Essentially, it's as if you would go every year for your annual physical at your doctor, okay? And say you look like a cover model, or say you look like, not even that, but the epitome of health, okay? You're not going to walk into your doctor's office and he or she's not going to say to you, you know what, I don't even know why you're here. This is unnecessary. You can go, just pay your copay. We'll see you next year. And whatever you're doing, don't change it. You look amazing. They're not going to do that. Why? Because you could have something going on inside of you. Despite the outward appearances and despite the way that you sound vocally, you could have something going on inside of you. You could have cancer, a blockage, precursors to a heart attack, high cholesterol. All those are the things going on inside of a body that could look perfectly healthy on the outside, but in the exterior could be fighting multiple, on the interior could be fighting multiple battles. And that is what we're doing combustion, because we just don't want to pay attention to the exterior. We want to get to the interior. That's the reason why your doctor, he or she, is going to do your blood work. The blood work will tell that doctor everything he or she needs to know, because it will show the interplay with the results that come back. It will show the interplay from one organ to the next and how the body is operating effectively as an ecosystem. Well, combustion analysis does the same way. It enables us to get under the hood, so to speak, and look underneath and really see how the patient is performing by looking at its vitals. For example, high CO in a system, akin to high cholesterol in a body. What's the recommended course of action? Doctor's going to give you a recommended course of action for high cholesterol. We will diagnose and we will make adjustments to the system to bring the CO to within specification. Okay? So an analyzer provides that kind of similar function. So what is combustion in a sense? Well, it's like football. It's like a collision sport, except we're going to collide three things together. We're going to collide a fuel source such as natural gas, we're going to collide oxygen, and we're going to collide heat or spark. And when we collide these three things together, it produces rapid oxidation. And the goal of the rapid oxidation is for us to derive as much energy from the burning of those fuels as absolutely possible. But if we are not maintaining that burn and we are not monitoring that burn with an analyzer, we have no idea what we're burning nor in what concentrations any of these criteria will show up as. You know, this tagline here across the bottom that says the best test while the rest guess, that is very, very appropriate for our conversation today. Because everybody, hopefully as a result of watching this today, will maybe think twice about testing. And when they think twice about testing, they're going to realize, you know what? I should not only test for the health, safety, and longevity of the equipment and the people that are occupying it, but I should do it as a best practice. There's three types of combustion. The first type is called stoichiometric. Stoichiometric is a hypothetical. It is a lab condition. It does not exist. It does not exist for two reasons, one primary, one secondary. Primary, it assumes that we have 100% oxygen in the air that we breathe, and we do not. For those of you that use an analyzer, know that we actually take in or breathe in 20.9% oxygen. The other 78% of that is nitrogen. The other 1% of that is others. And typically that others will be argon gas depending on where you live in the world. Okay? So we're already at a 5-to-2 disadvantage. The secondary reason we cannot have stoichiometric is that we have heat loss or thermal loss with every combustion process that we employ, okay? Stoichiometric says that we don't have that. So what are we left with in real world scenarios? We're left with two other types, complete or otherwise known as good combustion and incomplete, okay? Which is the most common? An incomplete occurs when we're not testing. These are the kind of results, these are the kind of things we see when we're not using a combustion analyzer. We're producing soot, dangerous conditions, high temperature conditions, and the like, smoky conditions, and it's a very unsafe scenario. But you don't know it because you're not testing, okay? And we wonder why equipment longevity is shortening over the years. It's only shortening because we're not commissioning it, maintaining it, and diagnosing it correctly. That's where an analyzer comes into play, obviously. Then we move over, if we start to test, we move over into this complete or good combustion. That is the best fuel to air ratio that makes sure that all the carbon and hydrogen compounds are used up and nothing is left unburned. We have the highest amount of efficiency, safety, and longevity with that equipment because we've set it up to go properly from the jump. You know, when you think about commissioning equipment, it's like raising a child. If you don't raise the child correctly, you let it run amok, use bad words, eat pounds of sugar, run all over the store, and misbehave, chances are, if that child has no rules, as he or she grows up, they're probably going to become a challenge in society, to put it nicely. It's the same thing with a system. If you don't commission it correctly, as it gets later on into its longevity cycle, the performance of it is going to fall off, and it's going to start to misbehave in the form of part failures, okay? Essentially, we think in our industry that everything we install from a combustion standpoint, from a heating standpoint, we think that everything is plug and play. Do you realize that people took, and they just did a study, that 85% of the furnaces and boilers that are installed today needed to be adjusted? 85. That's a lot. And I don't think that 85% of us are commissioning a piece of equipment using an analyzer, and that's an issue. And that's, again, hopefully what we're going to change today. Excess air, let's talk about this for a second. We're working in dynamic environments. Where you are working and where you're installing are living and breathing environments. People are opening, closing doors, turning fans on, changing the pressures inside of a structure. And then you take into account that we're installing equipment that does the same thing. It's living and breathing. It's taking in fuel. It has waste products in the form of what goes out the exhaust or goes out the stack. So you have two beings trying to live together and cohabitate. Don't you think that might take a little bit of adjustment? Hence going back to my statistic of saying that 85% of systems that we install are not being commissioned correctly and need to have an analyzer on them, at bare minimum. This is proof to that because we need some excess air in this situation because we have variations in fuel flow rates and an imperfect or an unbalancing between air and fuel. When we adjust the system and bring in a little bit of additional excess air, we can actually balance that equation because without enough excess air, we're producing the soot, the CO, and the dangerous conditions. But if we put in too much or we're not paying attention, we put in too much, we can have inefficiencies, the appliance, cooling of the flame, and some other characteristics that we don't want. So our goal with all of this, with combustion, as in anything in life pretty much, is to strike that balance. And it's a balance that can easily be struck with the diagnostic aid of an analyzer. 7 functions of highly effective analyzers. You can probably tell as we get to this part of the presentation, as we go through the rest, that I'm pretty passionate about this. This isn't just a job, it's also a hobby. You know, I probably should get out more, but it is what it is. But these are a very effective tool. And at the minimum, they do these 7 functions. They do combustion analysis, yes. They do ambient temperature, ambient CO, draft, gas pressure, because there's a pressure manometer built in each one of them. Can verify cracked heat exchanger on a forced air system, and can also verify for cross-contamination on installing any condensing system, okay? But you take it beyond that. And again, you go back to my original statement in the beginning of the presentation, where it's either going to give you a neon sign that says you must repair or replace this, or it's going to give you that series of breadcrumbs. It's going to do one of the two wrapped into these essential functions that it offers, okay? And not only the fact that it's a moneymaker, and we'll get into that a little bit later on. So, very important. How much is too much? Let's talk about carbon monoxide here for a second. In case you're not aware, in our industry, the average working life expectancy of a technician in our industry, believe it or not life, but working life expectancy is 56 years of age. 56. It is not because you can't get yourself in and out of a scuttle hole, in and out of a crawl space, in and out of an attic. We all know that that's what the apprentice is for. Just kidding. Just kidding. For those of you who know that with that, it's been asked to do that in life, you'll appreciate that. It's not because of that. And it's not because the technology is beating you, but that's what you think. It's not because of that. Listen, for those of us that do this like Craig and myself, we know you, we see all of you, we know what you're capable of. We know that you fix things for a living. That's not easy. That's not easy. Not everybody can stomach it, not everybody can do it, but yet it comes natural to you. So those natural tendencies that you've developed over all these years, they don't magically evaporate. But what's happening is that the CO, you're constantly exposed to it. If you're not using a combustion analyzer and you're not wearing a wearable CO monitor on yourself, you are exposed to carbon monoxide, and that's an issue. So by a daily basis, what's happening is that it's making an inroad into you, and it's affecting your cognition, and it's affecting your neural capability. When we talk about carbon monoxide, let's take a look at the levels that we have here. All you get is 9 ppm over 24 hours, 35 ppm over 8 hours in an office environment, as an example. And after that, as you can see, as you get lower and lower on this chart, the effects become damning, and eventually death occurs. So we need to take this seriously. Remember, when you go into a space, we need to have that situational awareness that I was speaking of, okay? So one of the things that you can do is to adequately monitor the space for carbon monoxide. So if you do not have a personal CO monitor, one of the functions of a combustion analyzer is that it becomes your personal CO monitor. And I'm actually showing our SICA 130 combustion analyzer here that we make at Sauermann, which we're very proud of. It's our flagship model. But this, as well as all of our other analyzers, can act as a personal CO monitor. This meets all the ANSI specifications, all the HRI regulations, and all the BPI standards as well for monitoring and also for combustion. So what we have is, when you first turn this tool on, the perfect way to do it, and the only real way to do it, is to turn this on outside in fresh air with no probes or hoses attached yet. Why? Because when you turn it on outside in fresh air, contrary to what people might think, it's not warming up for you. It doesn't like you that much. It is zeroing itself out to fresh air. So it's going to show you 20.9% oxygen, and everything else is going to be zero. If you didn't listen to me, and you started this up inside this space here, for example, and we had 100 ppm of CO in here, it's going to show you zero because you've negated the first 100. And then we go farther back in this room, and we go to go farther back in this building and go to the furnace room, and there's 200 ppm of CO there. It's only going to show you 100 because, again, you've negated the first 100. Okay? In addition to that, when you start this up outside in fresh air, please don't do this if you're a smoker. And blow cigarette smoke on the analyzer. Don't do that. And for those of you that are into vaping, and a lot of my friends vape, so I say this jokingly, I appreciate you wanting to spew your strawberry and grape and melon scented things into the air, and you think you're with the Beatles in a hookah lounge with all these pipes and all these hoses going into your mouth and everything else. Just kidding. I appreciate you vaping, it's fine. Just do me a favor, don't vape over this thing, okay? And if you're running your truck outside while you're starting it up outside because you're actually listening, don't keep this near the truck exhaust while the truck is running because that will also impact it as well, okay? So again, just something to keep in mind. So when we start this up outside in fresh air, the reason I don't want any probes or hoses attached is that I don't want to run the risk of the remnants of a previous combustion test that is sitting dormant in here, making its way into here and basically sullying or soiling the starter protocol in this analyzer. So start it up outside in fresh air, go through the auto zero, then you can connect your probe and hoses, which I'm going to do now. So now that we're all connected, what you're going to tell the homeowner or the business owner or the customer is you're going to say, listen, I'm just going to take a few moments to monitor the ambient environment for carbon monoxide. And they're probably going to tell you that you don't have to do that. I have a monitor over here, I have one over here, I have one over here. And what you're not going to tell them is the chances are the monitor that they have is not very effective. Those big box stores monitors that people get, and I'm not going to name names, but the ones that they buy, are going to go off after 70 to 300 ppm after 1 to 3 hours of exposure. Remember I told you, all you get is 9/24, 35/8. Okay, so it is far beyond that realm before those will even trigger. Okay, so you're not going to say to them, oh, I watched this presentation and what you have is a piece of garbage. Please don't do that. We want to be nice and establish a proper relationship with our customer. You're just going to simply say, with all due respect, I think it's great that you have them. However, this is a calibrated device that I can trust, and I'm just going to spend a few moments just monitoring the ambient environment. You're welcome to come with me. And if we see any CO show up on this display, we can then determine the appropriate course of action, opening windows, opening doors, and then finding out the source of it and getting everybody out of the space or out of the building. I'm just going to take a few minutes to do it. Once I know that you're safe and that I'm safe, then I can go ahead and I can do exactly what I was sent here to do today. And that's all you're going to do. But that's a very important step because you also should be doing it year-round. You're working in places that are running fuel-fired appliances such as ovens, stoves, water heaters, okay? They're all running at the same time while you're there working on the air conditioning. They're emitting CO. Again, situational awareness. It might not be what you were sent there to work on, but it's something that you can potentially save a life and diagnose correctly and take care of. So just keep that in mind, that an analyzer is a tool that should be used on every service call that you go on, or if you're wearing a personal monitor, make sure you're wearing that on every call that you go on as well. So just something to keep in mind, a little public service announcement. But let's look at the various sources of where we can be impacted by CO. For example, we have a generator running outside, we have a gas grill, car in a garage, clothes dryer, water heater, furnace or boiler, oven or stove, fireplace, or a blockage in a chimney. You know, specifically speaking here of the car in the garage, a personal friend of mine had a carpet cleaning service out to his place, and when they were cleaning his carpets, the house was buttoned up and the exhaust fumes were wafting into the house all day. And the CO monitors that he installed before he closed on the house 4 months prior never went off. They never engaged. And my friend returned home from a business trip that day to witness his two children, his wife and his mother, being taken out on stretchers. What happened was they got poisoned by CO, and his son had to be held overnight for observation. The carpet cleaning company in question, their technician was not impacted by the CO because every 4 to 5 to 6 minutes, he was actually going outside and having a cigarette break and getting fresh air, so he was not impacted. But the family members were, which just shows that even though you have a monitor, it might not go off, so you have to pay close attention to what you're doing and the proper monitoring of CO in a house. And we will have links in the description to some of the best CO monitors out there that you can go ahead and research and make the most effective decision for yourself. But again, keep in mind the various ways that it can infiltrate a space and impact it. And the two most popular are the stoves, the ovens, and the water heaters. And that is a year-round occurrence. And then after that is furnaces and boilers. So we have a couple of different things that we're going to go through here. We obviously went through the monitoring of the ambient environment for CO. We want to know or understand what the manufacturer's levels are. What does it say in the manual for the equipment that you're working on? Okay? You want to check the source of the CO. Again, remember, it might not be coming from something that you're working on. You could even have a neighbor's appliance that is stubbed out, that is blowing its exhaust, and it's going into somebody's window when you have structures that are very close together. Remember, not everybody watching this like you are is installing things and taking out the proper permits. Some people are doing things in an unsavory way, not licensed and not using permits to have their work inspected, and they're doing things in an incorrect fashion. And it's dragging us down as an industry, and we don't want that. So install your stuff correctly, but again, check the source of it because you could have inherited a problem. Use your analyzer correctly, like I mentioned. Know your levels, okay? And also the liability. And when I have know your levels, it goes back to the 9 ppm over 24, 35 over 8, but it goes one step further than that. I'm going to just briefly mention a general guideline now, and then I'm going to go over it later on in the presentation. For general, again, that is general industry purposes, 100 ppm or less of CO in the stack is acceptable. 200 ppm under steady state running conditions over 200 ppm on steady state running conditions is considered to be a potential red tag. So 100 ppm or less should be fine. We want it as low as possible or as negligible as possible, obviously. But 200 ppm or greater is a potential red tag situation when it is running at steady state operations. Now, you can have high fire at light off. There are other that light have high fire at running at a higher setting. But again, follow what the manufacturer says and make sure that you maintain the integrity of that system, but also pay attention to what it says in the manual. And understand the liability. You touch it, you're liable for it. Again, these people can pursue you, and they can also pursue your families legally as well, which I'll get to here in a little while. And what the bleep do these readings mean? A few key points. I've already talked about excess air. I'm going to talk about CO air free a little bit later. I want to talk about efficiency total and T-flu. Let's talk about efficiency total first. It says here, efficiency total 82.8. We're going to work in round numbers today. For those of you that are not aware, you can actually sell on the efficiency number that shows up on this readout here. It is not going to be identical to the AFUE rating or to the rating on the side of the piece of equipment. Why is that? It is because this efficiency rating here is the fuel utilization of that appliance. It does not take into account the other accoutrements that it might come with. For example, modulating, variable speed, high fire, low fire, all those different things. It doesn't account for that. It is strictly fuel utilization. However, it will run anywhere from 2 to 6% close to what the AFUE states. So it's going to run neck and neck with that. So, for example, you could take a piece of equipment that when you installed it 25 years ago was 80%. You could tell the customer, Mr. and Mrs. Smith, it's the best we had at the time, it's the best that you could afford, it's run great for you over all these years, but you could see the last 5 to 6 years, we've had a series of repairs on it. It's now running at 60% efficiency, as you can see by the readout that we've given you. So when we installed it, 20 cents of every dollar was going up the stack. But now, 40 cents or almost half of every dollar is going up the stack. We can install a high efficiency piece of equipment for you that's rated for 97%. And the day that we install it, depending on the day, it's going to range between 92 and 95 or 92 and 96%. So you're actually going to see the efficiency that you're paying for. So we want you to keep this 60% readout because we want you to have it for your records. And then we want to show you when we commission your equipment, because we're going to use an analyzer to commission it because we want to do it correctly, you're going to see that you're actually getting what you're paying for. So what are you doing here? You're establishing or further establishing the relationship and the trust with your customer. We look at our customers as customers, but we probably should change the mindset a little bit and say that we're establishing our relationship with our clients, because client always gives the connotation of a long-term relationship. So always think in the back of your mind, you can call them customer, but always think in the back of your mind, this is our client. This is our long-term relationship that we're looking to foster here. And one of the ways that we foster it is to commission it correctly and explain exactly what we've done. Okay? So that's where we can sell off on the efficiency on this sticker here, on this printout. And then we have T-flu. It's very simple, everybody, for T-flu. If you lower the stack temperature, you increase the efficiency. It's an inverse relationship. So as the stack temperature drops, the efficiency goes up. Why? Because when we're lowering the stack temperature, those therms or BTUs aren't going up the stack. If they're not going up the stack, guess where they're going? Into the space to heat it. So we're increasing the efficiency. So either you can look at efficiency in one of two ways. Either you can explain it with the T-flu and dropping the flue temperature, or you can explain it in the context of efficiency, whatever you prefer. Manifold pressure. Never assume all is fine. As Jim Bergman always says, clock the meter. I have to agree. It's hard to disagree with a legend, but I have to agree. Clock the meter. When we take it beyond that, we want to look at some things here. We want to look at what the fuel pressure should be from the manufacturer specifications. For those of you that are not aware, and you should test this for yourselves after watching this, gas pressure can change around this country in different municipalities on a daily basis. You're just not aware of it because you're not checking. That neat little device in your truck called the manometer, that's going to help you. Or, in better sense, a combustion analyzer like this is also going to help you because there's a pressure manometer built into here, and we have a manometer hose kit that goes with this. So you can actually use this to check and verify and have it imported into your report of the gas pressure. So, want to know what the manufacturer's specifications are. Typical nominal low fire is 1.7, High fire is 3.5. Typical ratings you're going to see are going to be anywhere. They're going to oscillate between 3.2 to 3.8. Higher settings can create an overheating condition, CO, very dangerous conditions. Lower settings can create a wasting of the fuel, flame impingement, and some other challenges. So what does this look like in graphical form? We could talk about this all day, but let's see what this actually looks like. So let's take a look at what we have here for a before and after scenario. So here's our before scenario where my pointer is pointing right now, if you can actually see that. We're at 35 ppm of CO, about 9% oxygen, and about 242, a little over 242 for a stack temperature, okay? And for those of you that use an analyzer right now will know or understand the fact that one of the fastest things to react when you make adjustments to a system is your CO. It could shoot up like a rocket ship. And I guess a lot of people, or I would assume a lot of people that are watching this have actually spiked their CO sensor, so they know what I'm talking about. And we'll touch upon analyzers later, but with our analyzer with Sauermann, we give you a way where that'll never happen again because we actually have programmable pump cutoff combined with an 8,000 ppm threshold. But it's an important feature to have because we understand how you're going to use it, okay? So let's take a look at the before and after here. So the before shows, again, these different levels. But what happens after? If we make an over adjustment to gas pressure, what happens after? Our CO shoots through the roof. Our oxygen starts to plummet. So our CO is up to almost 75, going close to 80. Oxygen is down to 7.5 already. And our stack temperature is heading towards 244, heading to 245. So by making an over adjustment to gas pressure, if left unattended to, it's going to shorten the service life, provide a potential safety issue, and hurt the efficiency of that appliance, okay? So we have to pay very close attention to the sensitive nature of gas pressure. Some of you will encounter that little sticker that says you can't adjust the gas pressure. Don't believe that. If a gas pressure adjustment needs to be made to make the system run correctly and to potentially save somebody's life in a situation where somebody getting sick, you need to make the necessary adjustments. You can worry about the warranty later. You know, it's going to be interesting when you go to court and you don't make that adjustment and somebody gets sick, if potentially that happens. The judge is going to say to you, you could have adjusted gas pressure, why? And you're going to say, I didn't want to avoid the warranty. It's probably not going to make you look very well. We want to prevent those issues, okay? But if you didn't think gas pressure was important, I think you might now. This is what a gas pressure issue can cause. Massachusetts, September 14th, 2018. 1 dead, 12 hospitalized, 39 homes destroyed. The one person who died, young man, was sitting in his driveway listening to his music in his brand new used car that his parents bought him because he just got his license. And the chimney came off his house when the explosions took place, landed on the roof of his car and killed him instantly. Highly, highly unfortunate. Nobody should have perished. No equipment should have been destroyed. And then the 39 homes, and then we have the 12 people hospitalized. So here's what happened. The situation was that they were pursuing legally the last technician that had been to any of these properties over a 12-month period. Thankfully, this technician had used an analyzer. And when he gave his statistical information from his analyzer, he had all of his O2, CO, and CO2 and the like. But one of the other things he had on his printout or his report was the gas pressure, which happened to be 3.5 the day that he was there. Remember I told you in the beginning, the very beginning with the Chuck Norris slide. You couldn't control what happened before you got there. You can't control what happens after you leave, but you sure as heck can control what happens while you're there, which is what he did. He did his testing like he was supposed to, because again, after he left, all hell broke loose, for lack of a better way of saying it. So what happened was this. He went to court, and at the time he was going to court, he was being sued in the millions of dollars. They were suing him, they were suing his parents, and they were suing his sisters, okay? He was released, though, when they went through all of his data, because all of his combustion numbers were perfect and his gas pressure was perfect. But they found out through further investigation that a gas company in question that was fueling these properties here, instead of the gas being delivered to these properties that day in inches of water column, wait for it everybody, it was delivered at over the rate of 200 PSI. They could not confirm nor deny that their system was not pirated. Sensors were removed and regulators were taken off. You know, I showed that slide in the beginning of the KissCons with the pyrotechnics with the furnace. Well, this was different. Witnesses' accounts were that when they went to turn on their gas stoves or ovens, stoves, that the flames actually shot up like they were at a KISS concert, and they came up to the ceiling. The 39 homes were destroyed. thankfully, and it was one too many, those 39 homes were the only homes that day calling for their domestic hot water off their boilers at that time. They said that if this was a demand day for heat, all 12,000 houses on that grid would have gone up, plus a lot of the adjacent homes from the spreading of the fires. So this was a catastrophe that should have never happened. Again, it was not caused by a technician doing something wrong, but it was a technician saved himself from liability by actually doing his job when he was there. Did his testing, did his gas pressure. So again, as I mentioned to you before, gas pressure can change on a daily basis around the country. It's something that you want to account for. So we never want to have this happen to anybody ever again. And that company can no longer practice in Massachusetts, Connecticut, Rhode Island, Pennsylvania, and Ohio. The gas company themselves, they can no longer practice there because of this issue. So it was a challenge. If you Google it, you can research it, you can find it. And one more image to make the point. Whenever we want to come home and see that be our residents or understand that we had a hand in something like this happening. So again, keep your side of the street clean. You won't have to worry about it. Gas leak detector, technician essential. It's a key to job site safety. This is going to detect all combustible gases for you. It's going to prevent potential challenges to whatever you're doing on a job site. It's also going to help you verify that the system's been installed correctly with no leaks. You know, I mean, natural gas has a scent to it, but propane obviously does. But this is going to prevent any kind of issue from happening. This is going to be your everyday carry for you. This is going to keep you out of a jam, prevent you from having any kind of liability for any kind of gas leak situation. So if you don't have a gas leak detector, I strongly suggest that you get yourself one. The importance of draft and combustion analysis. Draft is extremely important. It is a pressure measurement that lets us know the rate at which the byproducts of combustion are actually leaving or terminating the actual system itself, the combustion zone, and actually leaving and going up the stack. So we talk about draft, we want to measure it under steady state operating conditions, usually within 5 minutes of when we hit steady state, okay? When we talk about it, we also talk about it in two different contexts. One in the context of an atmospheric system, the other in the context of a condensing system. So I have here measuring draft and ensuring proper intake air in a dynamic environment. Because remember, you're working in living and breathing environments, installing something that is going to be living and breathing. So you have to make sure that everybody plays nice in the sandbox together. So we look at atmospheric. Our inches of water column for that are minus 0.02 to minus 0.04 to make sure we have proper draft. But because it is taking air from the actual space it is in, taking its room air in, it has a different set of operational characteristics or things that can impact it. So we can have a barometric damper issue, we could have issues with chimneys, we could have an incorrect stack size. I don't understand why we think we need to re-engineer a system that's been installed correctly for years. We go to put the flue pipe on and we put the wrong size on. And a lot of the times when I hear that excuse or hear the excuse for why they did it, it was, that's what I had on my truck. Well, guess what? That's why we have parts runners. That's why we want to do the job correctly. That's why we don't want liability. So please make sure that you're putting on the correct stack size on there so that you don't have issues going forward, okay? But we also can have a competition for makeup air. So there's a host of things that are going to impact the way a system drafts and the way that it is taking in its combustion air. So let's take it, again, from an air quality perspective with a system like this. Have you ever had to step over boxes or move things out of the way from a furnace room or boiler room that people have put right there? Right? It's an issue, correct? Or have you ever found paint cans or solvents that are sitting right by a system? Guess what that's doing? That is either restricting airflow, getting to that system, or the off-gassing of those paints and solvents is impacting the quality of the air that that system is taking in. Again, as I mentioned before, anything lower than 20.9% oxygen is an issue. So if you have anything that is kind of dropping the percentage of oxygen by its off-gassing, that's a problem. You know, when you talk about an atmospheric system. Let's talk about a condensing system for a second. A condensing system works differently than an atmospheric. As we talked about, an atmospheric is using room air, taking in makeup air, room air for its combustion, and which is obviously influencing its draft as well. But with a condensing system, it is taking fresh air from the outside, which is then it's using for its combustion, which is obviously influencing its draft. But some of the things that influence a condensing system's draft could be an induced draft motor issue. There could be an exhaust vent blockage or a vent done correctly. There could be, let's go back to the blockage for a second. You could have a rodent making a nest in there. You can have kids sticking balls in there or action figures in there, and they try to see how much they can wedge down into there. That could cause an issue, okay? So we want to make sure that we have our exhaust and our fresh air intake clear of obstruction, okay? Once we verify that, and then even when we're installing, we want to test or verify the quality of the intake air. And that's one of the functions of an analyzer. It's function number 7, is that it can verify cross-contamination on a condensing system. Because as I mentioned earlier, we're returning things at the rate of 25 to 35% that we think are defective. They're not, chances are. They're being vented incorrectly because it's been an oxygen issue from what the manufacturers have told us. So what's happening is that we have chances are less than 20.9% oxygen making their way into the system. So what you're going to do, and this goes into whether you're installing or whether you're maintaining it or diagnosing it, you're going to put your probe in the fresh air intake. And you're going to look at your screen on your analyzer, and you're going to verify that you have 20.9% oxygen. If you don't have 20.9% oxygen, you have cross-contamination. That cross-contamination could be coming from the system you just installed, where you put the exhaust too close to the fresh air intake. There could be another appliance in that space that is impacting it by the way that it's drafting, or you could have a neighbor's appliance that is stubbed out, that is putting out its combustion properties, and your fresh air intake is pulling it in. Something else to pay attention to is when we're planting bushes on the side of a house. Sometimes you have a nice sparse little bush when the system's installed and everything's fine. But 10 years down the line, as that bush matures, it could create an air curtain almost. So when the exhaust properties come out, they could deflect off the bush, the fresh air intake could pull them back in. We've seen it happen before. So these are all the things that we need to pay attention to when we're at a site. We kind of have to look, see the forest for the trees, so to speak, and make sure we're vented correctly. So if you have not been using an analyzer to verify cross-contamination or if a system is vented correctly outside of measuring, if you're not using it for that, you should. And you can also use it for your diagnostics and your maintenance as well for this purpose. Commissioning a new piece of equipment. If it's new, why do we need to test? Well, you assume it's set up correctly. Every factory is different. Factory workers could have had a bad day. They're men and women working in there just like us. They could have had a bad day. They're human, okay? We have, again, that false presupposition that everything we install is plug and play. Remember, I told you, at least 85% of it is not. At least, and that's at the bare minimum. So, like a new car, needs a little bit of a massage, needs a little bit of love to make sure it's operating correctly. Setup can change in transit. Things can become jostled and shaken, unseated, gasketing can fall off. We don't know. We have to verify that. New equipment is set up at sea level. Depending where you're at around the country, you might have to make an atmospheric adjustment in the analyzer to account for that. Okay? What is the pressure? What are the conditions where you're at? What is the gas pressure where you're installing? I think I pretty much hit home on the importance of gas pressure, but if I did not, again, it could fluctuate and change on a daily basis around this country. Make sure you're verifying what that gas pressure is and make sure you're clocking that meter. And then your commissioning instructions for the unit are typically, or should be, inside the manual with parameters for O2, CO, and CO2. And there are industry publications that will actually give you, for the different equipment that you're installing, what those parameters are in the event that you don't see it in your installation manual. And then venting. You want to check the install manual to make sure that you have the system vented correctly and you have the appropriate intake air coming back to that system and that it is vented properly with the proper clearances, proper duct size, and everything else, and pipe size. Seasonal maintenance. Why should we combustion test every time we engage a field-fired appliance? Well, you touch it, you're liable for it. Remember, you're the expert. You're the one everybody's paying to see, all kidding aside. But you're the expert there. You are the one that's supposed to know exactly what you're doing. So if you touch it, you're liable for it. And you're even could be potentially liable for things you're not even touching at that moment as well. You can't tell how it's running just by looking at it. Looks can be deceiving, as I mentioned before. Do not judge a book by its cover. It could be the healthiest looking patient, the healthiest sounding patient. Don't judge it based on that. Do that system's vitals. Again, you're going to use a manifold gauge set on air conditioning. Going forward, now you're going to use an analyzer when you diagnose, maintain, and commission a fuel-fired appliance. Did the last technician leave it running correctly? You could have had the best technician have the best day and the worst technician have the best day of his or her life. They could have worked flawlessly. It doesn't matter. Things can change from visit to visit. You don't know. People can make changes to their building or their structure or their home in between visits. gas pressure can change, all those other things can change, as I have here on the bottom of the gas pressure. All those things can deviate and change. We need to account for those as if every time it's fresh and new like we've never seen it before. And then, is the draft correct? Did you verify? One of the things that we can do with our analyzer is we can actually, because we have an app that goes with it, is we can have the analyzer mounted, and we could be away from the analyzer on our app, and we can look at the impact of when we're turning on and off interior fans in a structure, opening, closing doors. We can see the impact of the envelope of the house that we're making by those opening and closing and turning on fans and what it's doing to the draft. Because we want to see the draft function under all types of different conditions when we're not there. And we can actually see that remotely, which is a pretty useful function. But again, when we're verifying draft, we want to make sure we have done that correctly. Did you do the blood work, aka the combustion analysis on that unit? Did you get below the hood? Did you get to see how the patient is behaving? Okay, that's where this comes into play. Seasonal combustion analysis checklist. Make sure you're checking these items every time you are on a visit, and don't assume that they are fine. You want to look at draft, gas pressure, do a smoke test if you're working on an oil system, very important. Do your combustion analysis, cracked heat exchanger verification for forced air systems, which I'm going to go over, cross-contamination for condensing systems, which I've already touched upon, and then also your ambient CO monitoring. I can't stress enough the ambient CO monitoring as well. That's when you first get there. You want to make sure that everybody is safe and everybody is going to be in proper working order when you're done. Using your analyzer as a diagnostic tool. How can we find, solve, and prevent issues using a combustion analyzer? 3 pillars: diagnose, solve, and prevent. Diagnose. What direction is the analysis pointing you in? Do we have a cracked heat exchanger? Do we have a leaky valve? Solve. Whatever parts have to be replaced, you're going to replace them. But after you do so, you're going to test again. Why? Because your first report showed this, where the numbers were askew, which led you, again, as I mentioned, either it was the neon sign that it gave you on the report, or it was a series of breadcrumbs that led you to this repair. So you're going to verify that the report that you did is correct by doing another analysis. So when you do the other analysis, your numbers now, your data should now be in check. Your statistics for your O2, your CO, your CO2, gas pressure, whatever the case may be, should all be within industry specifications once you've done that repair, and then you know that you've repaired it correctly. So again, as a diagnostic tool, it is very important. And then you're going to prevent. You're going to test at every visit to prevent costly repairs and issues. You're going to be that pro and proactive. General diagnostics insights. A sample of things an analyzer will show you to aid you in diagnostics. And this is a very small sample. And this whole presentation today is a very small sample of what we do. Normally it's a lot longer than this. I'm only kind of touching upon the basics. But from a diagnostic standpoint, we really drill down very hard in live presentations and all other aspects of combustion. But for purposes of today, of keeping it concise, CO2 spike of 2,000 ppm and above at light off. Possible indicator of delayed ignition, possible igniter issue. Do we even have simply a thermocouple issue? O2 spike when the fan comes on. Do we have a gasket issue? Do we have a crack in a primary heat exchanger? CO spike at shutdown. Possible indicator of a leaky valve. Don't know, we got to look further. High CO and high temps. Possible over fire condition. Again, we really drill down on those types of things in the longer live presentations. And then draft not within spec. Do we have a draft inducer issue? Do we have a blockage? Do we have a barometric damper issue? Did a kid stick all their action figures in the flue exhaust and we have zero draft? Did a bird take up tenement in there? We don't know until we actually inspect that. So, as you're seeing, as we're getting to this point, an analyzer is far beyond O2, CO, and CO2. It's a very helpful diagnostic tool, very helpful maintenance tool, and obviously critical and very helpful commissioning tool. Okay, so it should be an everyday carry for you, and you're seeing, hopefully at this point, that we're kind of building to that should be something that should come to your mind now when you're doing your daily activities. Okay, here are some general tips and advice that I want to give you for combustion analysis, and these will hopefully simplify your testing. And again, just a small sample. High efficiency systems get tested no less than 1 foot above the inducer outlet, but no greater than 2. Efficiency, as I mentioned earlier, relates to the combustion efficiency, which is fuel utilization. It is not the appliance's overall efficiency. Remember, it does not account for modulating, variable speed, all the other accoutrements of that system that enhance its capabilities, that make it, high efficiency. It does not account for that. But it does look at the fuel utilization, and it will be within that 2 to 6% of what the actual sticker says for the unit. Evaluate oxygen during the entire combustion cycle and check for stabilization, escalation, and decline. I want you to look at everything, okay? I want you to look at the patient when it's young, the patient when it's at midlife, and the patient when it gets older, as far as a run cycle is concerned. I want you to look at all the attributes and characteristics and how it's behaving, because that will aid you in your diagnostic approach, and it will aid you in fixing something before it gets worse. Because with combustion too, when it comes to diagnostics, what you're trying to do is you're trying to prevent an issue from happening. You're trying to prevent a catastrophic failure in that equipment where, with all the supply chain shortages that we have, you might not be able to get their part pretty quickly. But if you maintain their system correctly and you start to see symptomatic things that the analyzer will show you, you can then order that part in advance and say, listen, it's not dead yet, but it's heading that way based on the way the statistics are showing me for your combustion analysis. Let's get this part in-house now so that we have it, so that when we go to replace it, we don't have to wait for supply chain issues and everything else that will negatively impact us. Because we all know that part's going to fail at the most inopportune time. Wednesday night going into Thanksgiving weekend, Christmas Eve, New Year's Eve. Okay, so we want to prevent that. Then CO guidelines. As I mentioned to you earlier, I'm going to state it again as I promised I would. 100 ppm or less in the stack is acceptable. 200 ppm or greater under steady state conditions is a potential red tag situation. When I talk about red tag, something else I want to state. All the technicians that are watching this and all the people that own contracting firms and everything else, you should all have a red tag protocol in your companies. What does that mean? That means that if you have to red tag a system, you have to have an actual modality or procedure in place so that you don't leave that technician, he or she, out on an island to have a homeowner or a business owner and get very upset with them. Because when you're delivering that your system is dead scenario to somebody, it can be very sensitive. I've heard of technicians where customers have threatened them with a gun. I've had it get physical, or I've heard of getting physical with customers, getting physical with a technician, because nobody wants to wear the hat of responsibility. The homeowner or the business owner doesn't want to absorb the fact that it's their system that's misbehaving. No one's broken it on them. It's their system. But the technician always gets blamed, okay? We want to have that protocol in place so that we don't have, say for example, a very young tech, or an inexperienced tech, that goes to a job site and red tag something. That technician could have all the potential in the world, but you get a customer that's going to berate them and scream at them and give them a hard time. They might say to themselves, why am I doing this? Why do I need to do this? I can go work for a home theater company, run HDMI cable all day, and no one's going to yell at me. And then what happens is we lose another good technician to another trade. And it's hard enough, as you all know, it's hard enough to find very good technicians. We want to keep the ones that we have, and we want to foster our relationships with them and bring them up and help them level themselves up. So part of doing that is to have a red tag protocol in place so that you bring another person in to have that second opinion, say, yep, this is definitely a red tag situation, I got to shut you down. And then within your own companies, you have to determine what is the best way you're going to handle that will limit or alleviate liability, but while also maintaining a relationship with your customer. So that's something to keep in mind. Does that CO spike at startup? Does it come down to level within spec, and does it spike at the end of a cycle? Okay? Something interesting with all this here. I want you to test at every fire rate. Okay? And I'm just going to speak about product for 2 seconds here. Part of the issue we've had coming up to this point is that we never wanted to test at light off because we run the risk of spiking this RCO sensor. We've all been there. You know that it happens. It's unfortunate. It's happened to me in the past. It's unfortunate. But now we, especially at Sauermann, have understood that. And one of the things in our ethos of design by techs for techs, one of the things that people in product development, such as my colleague Bill Freed, who's in with me at Sauermann Americas, one of the things that he put in and made sure that we got was the programmable pump cutoff for your CO. And my colleagues did as well. The programmable pump cutoff for the CO. So you're never going to spike your CO sensor again. It comes factory set at 2,000 ppm. So once the CO hits that, the pump automatically cuts off and prevents it from drawing in any more of a sample. Now the threshold is 8,000, so you can raise that up, that pump cutoff. You can lower it down. It's customizable. You can even turn it off. I don't recommend that you turn it off, but you can turn it off if you want to. But it's there for your protection. That is why in our trainings now, we're hoping to change the narrative where we want you to test at all those different times. We want you testing at light off. We want to see the most hellish conditions that thing can produce. We want to see steady state, and we want to see it at shutdown as well. So just something to keep in mind. Testing at all levels we think is the most important. And I know that, for example, National Comfort Institute, who uses our analyzers, they want you having at least 3 tests when you produce any kind of combustion test that they recommend that you do in their trainings. I want to talk a second about CO air-free and CO and regular CO. So CO air-free is like a bourbon neat, thus not diluted at all. Whereas CO is like a bourbon on the rocks, thus diluted by the ice in the glass. So when we are monitoring combustion, I don't want any dilution in there. So I prefer that you use CO air-free, as do other experts in the industry as well. However, when you're monitoring the ambient environment, using regular CO is perfectly acceptable. Basic combustion testing procedure. Just want to briefly go over a proper protocol for combustion testing, and hopefully this will kind of clear up some of the mystery if you've never done this before. One of the things I do want to point out on the slide here is right here. This is a positioning cone. I'll actually show you what this looks like live on camera. Right here. This is a positioning cone. This actually goes into the actual flue pipe and screws in. It is threaded, okay? It is meant to keep it stable, because if we don't have the positioning cone, we just put the probe in, we put it this way, and it's all slanted, doesn't look well. And all of a sudden the probe falls out, and we're like this, I got it. What do you have? You've gotten burned. We don't want to get burned. So we use this positioning cone, which we thread in first, and then we put our probe into that, and we screw it down. What happens is the probe stays nice and stable. Okay, we use the positioning cone. Just something to keep in mind, because I've seen technicians take that out of their tool, take that off the analyzer and think they don't need it because they don't understand what it's for. So when we put our probe in, one of the things I want to make sure I make clear is that the simplest way to know if your probe is positioned correctly is to go roughly 6 to 8 inches above that breech. But when you put your probe in, you can bottom out. What you do is you bottom out, you kiss the back wall, and you slowly disengage. You always want to have the probe roughly midway into the stack. From a circumference standpoint, so midway in. If you keep hitting the back wall, or all you actually use a regular probe to do this, if you actually hit the back wall, there's a hole at the end of this probe. You're going to restrict the amount of sample that is actually making its way to the analyzer, so you're going to lengthen the reactivity time of it. So you always want to you can hit the back wall, slowly disengage so you're midway in, and then secure this nut on top of the positioning cone, and you're in good shape. Just a general rule of thumb. So turn your analyzer on outside, do that fresh auto zero that I mentioned earlier. Then you're going to connect your hoses and your thermocouple. Enter the structure. You're going to perform your ambient CO test. While you're doing so, you're also going to ask the homeowner or the customer, is there anything else I need to know outside of what was on my call list, what I'm here for? Because there could be something that is manifested itself from the time that you called last time until the time that you're there now that you might want to take care of. Then you're going to start the appliance up, furnace or boiler, etc. Verify the gas pressure set correctly, and then make sure you set the correct fuel on your analyzer. Because if someone else has used it and you're working on a different fuel, your numbers are going to come up askew, which I'll go over here in a second. Then you're going to locate the proper testing point, which again is 6 to 8 inches above that breech, and then put the probe roughly midway in, secure your positioning cone, and then you're going to start your testing. You're going to evaluate the combustion during light off, steady state, and also shutdown, not just at steady state. Remember, all 3 cycles I want you to test. But when you're verifying your draft, I want you to verify your draft when it is under steady state. And your draft reading should be roughly -2 to -0.04 inches of water column for an atmospheric system on the negative side. And for a condensing system, it's +0.02 to +0.08 inches of water column. So keep that in mind when you're doing your draft. Post-testing procedure. Take your probe out of the stack, okay? But don't put it down yet, okay? Because it's going to be very warm, or it's going to be warm. What you're going to do is after a minute or so, you're going to start to kind of feel the radiant heat coming off of it. When it feels like it's no longer hot, you just kind of tap your hand, then you can put it down. Now, when you put it down, please do not turn this off yet and don't disconnect the probe and hose. Why? Before you turn this off, I want you to make sure that you have 0 CO on your screen. Why is that? Because when you turn this off, it's going to go through a purge. The purge isn't based on the levels the analyzer is reading. It doesn't like you that much. It doesn't interpret that data that way. Purges are always set on a timed basis. So for example, if you had 30 ppm of CO on here when you pulled your probe out of the stack and you hit the off button, no analyzer out there is going to purge 30 ppm out of it within a 30 second to 90 second runtime for its shutoff protocol. It's not going to happen. So if that's the case, CO is going to be sitting on here, or sitting on these sensors when the analyzer is dormant. A CO sensor's life is like a boxer's life. A boxer can only handle so many body blows and headshots before that boxer has to retire. CO sensor is the same way. It can only handle so many body blows and headshots. So if you turn this off while there's 30 ppm of CO on there and then CO is sitting dormant while the analyzer is not functioning, that's like someone going into the boxer's bedroom and beating on them while they're sleeping. They're not going to like that very much. It's the same thing you're doing. You're beating on this while it's not working for you. Because every time it's working, it should be making money for you. So you want to enhance its capability to do that and follow this procedure. If you do, your sensor longevity is going to be enhanced. So make sure it says 0 on your display before shutting it off. Then you can hit the off button. But when you do hit that off button, do not disconnect the probe and hose yet. You want to wait for it to shut itself off completely. Because when you hit the off button, it's going to start that purge that I mentioned. But what it's doing is it's purging any combustion byproducts out of this analyzer, out of this hose assembly, and out of the probe. So when it's doing so, what it's doing is it's going to leave you with a completely clean bill of health for when you go to use it the next time. Once it shuts itself off completely, then you can disconnect the probe and hose, put everything in its case, put it away, move on to the next thing. Combustion efficiency. Let's talk about 2 different systems. First, atmospheric. Atmospheric is pretty basic. We're looking at the fuel, the CO2, and the delta T. So we have a stack temperature here of 300 degrees, and we have an ambient temperature of 70, gives us a delta T of 230. Now, when we're doing combustion efficiency, whether we're talking about atmospheric or condensing, it is very important that you select the correct fuel. Why is that? Every fuel has a coefficient assigned to it. It's an identifier. So for example, I'm just going to pick a random number. Natural gas might be 0.076548286753009. It might be that. That number is multiplied by the percentage of oxygen that the analyzer is reading. The answer to that multiplication is what gives you your CO2. You have an oxygen sensor? Yes. You have a CO sensor? Yes. You do not have a CO2 sensor. CO2 is a calculated value, and it is calculated with that actual equation that I just gave you. Okay? So it's very important that you select the correct fuel, because if you don't select the correct fuel, your efficiency is going to be off, your CO2 is going to be off, and it's going to skew the way your results are produced on that actual test. So again, pretty basic for here. Nothing else to account for, nothing crazy that you need to do. This is where things change. We have been doing combustion efficiency wrong in our industry on condensing systems for years. You have never been taught, because no one's ever taken the time to do so, or you've just never learned from another technician. You've never been taught that you need to take the temperature of the intake air. A lot of analyzers out there don't give you a secondary type K thermocouple in the bottom like we do, which means you don't even think you have to do anything different. You just use the ambient air. But you're doing your combustion efficiency wrong with a condensing system, because the delta T, if we were to use 70 degrees on this previous slide here, if we use that here, that means our delta T is only going to be 30 instead of 80 like it is here. That's like you telling the customer, listen, I knew we were good. I didn't think we were this good. We installed a 96% efficient system for you, but check out our report. It's running at 112%. We're the greatest. It doesn't work that way. You took the wrong number. You need to take the temperature of that intake air, which is where an analyzer comes into play. we give you a separate Type K thermocouple port to plug in either your own Type K thermocouple, one that you can get from us, but you use that same hole that you use to check the quality of the intake air that I told you about earlier for cross-contamination. Use that exact same hole, but you put this Type K thermocouple in there, and as soon as you plug the Type K thermocouple into the bottom of this analyzer, it automatically knows you're doing a condensing system, bypasses taking the temperature from the temperature sensor in here, in the analyzer, and takes it from that external probe, that Type K thermocouple probe, and populates the system correctly and automatically calculates the combustion efficiency for your condensing system correctly. Now, if you don't have your own Type K thermocouple and you don't have mine or ours at Sauermann's, we actually give you a way to manually go in, override the temperature that it's reading. All you're going to do is you're going to go onto your phone, pick the Weather Channel app or whatever app you want to use. You're going to look at what the temperature is where you're standing that day outside. It's going to tell you, you're going to type that in, and as soon as you type that in, the analyzer will automatically provide for you the correct combustion efficiency. So, many ways to get to Rome. Whatever way works for you is the most appropriate way. But if you have not been doing combustion efficiency this way for a condensing system, you have been doing it wrong. Hopefully you'll correct that going forward and use this going forward. As we get close towards the end here, let's talk about cracked heat exchangers for a second. So what do we do now for cracked heat exchanger verification for forced air systems out there, everybody? We typically do visual inspection, right? What I might see, Craig might not see. What Craig might not see, someone else might see. We have, amongst the contracting world, or even in your own contracting firms, you have variability of experience level. There's experience levels that are all over the spectrum. Well, variability to a contracting firm equals liability. Liability is a headache, and nobody wants a headache. If you want to level that playing field where an apprentice or an expert can condemn a cracked heat exchanger in the exact same way, you want to use this. This is your constant companion, and this produces a repeatable result time after time after time and takes the guesswork out of it. So, if you have been using combustion analysis for your heat exchanger verifications, this will be interesting for you and you're going to use it going forward. We have had technicians, not only myself, but the other training experts and the other experts in this industry around the country and around the world have had technicians use them for this purpose, and it has produced tremendous results and tremendous amounts of profitability. Because when you do it this way, this is not snake oil. This is not bait and switch. This is not deceptive. This is real statistical data that you can actually show somebody and prove exactly what this system is doing. So let's take a look at that. So this is going to be the same thing for any forced air system. You can even obviously do it on a rooftop. If the system is running when you arrive, let it stay at steady state for another couple of minutes, 3-4 minutes, shut it off, let it mellow out. If the system is not running when you get there, turn it on, let it run, let it get to steady state for a few minutes or 5 to 6 minutes, shut it off, let it mellow out. Why are we doing that? I want to establish a baseline of behavior with everything. I want to control all the variables, and I want you to as well. Once you have that baseline, obviously assuming you would have taken your analyzer outside, auto-zeroed it in fresh air, connected the probe and hose, monitor the environment, especially now wherever the furnace is located, we want to make sure that you're still getting external to that furnace, so the probe's not in it and not in the stack, you're still getting 20.9% oxygen right wherever that equipment is located, okay? Then you're going to put your probe in the stack, use your positioning cone, lock it into place, put the probe in midway, remember don't bottom out. Then you're going to turn the system on. You're going to mount your analyzer, turn the system on. When you do so, you're going to see your oxygen plummet, and you're going to see your CO on the rise and your CO2 on the rise. Remember, you're no longer measuring conditions in the ambient environment, you're actually measuring combustion byproducts in the stack now. So combustion is going to begin, inducer is going to start, all those other things are going to go into play. Within 10 to 15 seconds, unless you've jumped it out, within 10 to 15 seconds, the fan is going to come on. But right before that fan comes on, you're going to see the conditions stabilize. So as the oxygen is going crazy, you're going to see it kind of do this and kind of level off and stabilize. So say for purposes of our conversation today, it stabilizes at 6%. Great. Then that fan's going to come on. And now I really want you to look, because if that oxygen goes up 2% or more, chances are you have a crack. Because remember, This is a sealed combustion party. No one else is allowed in. I don't care who you know. I don't care what you're wearing. I don't care what your hair looks like. You're not getting in. It's a sealed party. But someone's come in through the back door and they've banged in a back glass pane and they're trying to get in. That's, in a sense, what a crack in a heat exchanger is like. Because when the fan comes on, it creates negative pressure. So it's constantly sucking in. But it can only suck in so much pressure with so much oxygen because that's what's supposed to be contained. If you have a hole, it's constantly sipping. It's doing this. It's going, okay? It's constantly sucking in, driving up that oxygen number. Because remember, you have an uninvited guest. That uninvited guest that you didn't call for, because remember, you're not making adjustments yet, that uninvited guest is in the form of additional oxygen that is coming in through that crack in the heat exchanger, thus driving up the percentage of oxygen that the analyzer is reading, thus denoting the potential of a crack. Now, having said all that, it's a magnificent tool. I don't want you to abandon all your technical abilities and hold this up to a customer and go, look, you got a cracked heat exchanger, here it is, let's get going here, let's get this replaced. No. Let's pause for a second and still try to get a picture of the crack as well, okay? Very, very important to do that. Still try to get a picture of it, but again, this is verifiable, this is repeatable, you could do this over and over and over again. It takes the liability out of it. So whether you're an apprentice or an expert, you can do this test. We had a contracting firm up in Michigan, beginning of this heating season, after they bought our analyzers, and they had their apprentice condemn 2 systems in the first week. Both times they did not believe that she had condemned them correctly. And they went out, because she's an apprentice, and they went out to verify. Both times she was 100% correct. She used her analyzer correctly because the service manager went out and his numbers were exactly what hers were. Both different job sites, both condemned correctly. So again, it's repeatable. Doesn't matter your experience level. You could still do the process, but again, still try to get that picture as your extra layer of proof or of backup, and to not abandon your technical ability and letting the machines take over, as it would. So hopefully that assisted you. So we go with, again, a 2% uptick or greater. We used to go with around a 1% uptick, but you have to remember there's variability between electronic tools. The safest bet industry-wide now is a 2% uptick in oxygen, as a general rule. Couple things. We are proud to announce that we are now the official combustion analyzer provider for NCI, National Comfort Institute. That is myself with the godfather of combustion, Jim Davis. NCI is the most elite training entity in the world. They're United States based, but they're the most elite training entity in the world. They've researched all the other analyzers on the market, felt that ours were the best ones that met their needs for the way that they train and the level of accuracy and proficiency that they needed. This partnership was born, and we are very, very happy and very excited for it. We were just at the NCI Summit back in April, which we were very flattered to be there, to see all those like-minded people and all proficient technicians that were there, and their companies as well. And another thing pretty nifty for us, we are now the analyzer of choice, or the analyzer, on the measureQuick platform. So if you go onto measureQuick now, you actually will use our analyzer. You can get right onto the measureQuick platform. And measureQuick is an app-based platform that aids in commissioning, diagnostics, and maintenance, provides a score to a system, and has a whole slew of integrated tools and modalities there that help you become a better technician. Because as technicians, we're very good at fixing things. We're not usually very good at selling things. This can take a technician who can't sell anything, can also make he or she a salesperson, because it will aid them with the scoring of the system, and it lays all the data out for the appropriate decision to be made. And you want to see the folks at measureQuick and Jim Bergman over there, and they'll be able to give you a full rundown of how their system works and how effective it is. But we are proud and honored to be a part of it, and we look forward to what we're going to create together, both with them and with NCI. And an additional announcement, NCI and measureQuick have now partnered as well. So they are now together. So the NCI protocols are now going to be incorporated into the measureQuick platform, and there's other things that those two parties have up their sleeve to enhance our industry, and I can't wait to see what they're going to do for all of us. So the future has arrived. We have 3 analyzers here. we have our 030, our 130, and our 230. I happen to have the 130 in front of me here today, which is what we're going to focus on. But just to kind of give you the differences here, our 030, residential light commercial, our 130, residential commercial, and our 230 is industrial and then all the way down. So you can add NOx to the 030, you can add NOx or low NOx to the 130, and you have all a different suite of up to 6 different sensors you can have in the 230. These two here, the 030 and the 130, they come with a 8,000 ppm CO sensor, and the 230 comes with a 10,000 ppm CO sensor, even though it says 8,000 there, 10,000, and has up to 50,000 with dilution. Some of the other subtle differences, not so subtle. This has a color screen with 4 buttons. This is a full color touch screen, and obviously this is color touch screen. The 130 is our flagship model, which we'll get into in a second here. But this is some of the reporting that we produce. With Combustion, for those of you that have used Combustion up to this point, one of the things that's been a problem for you, and you told us and we addressed it, was everything looks like a grocery store receipt that prints off. Everything. Or that we send to our customer. We send them this grocery store looking receipt, they don't know how to interpret the data. Well now, with our app and the way that we produce our reports, you can actually create a 3 to 10 page comprehensive report with everything from up to 8 job photos that you can take either from our app or from your camera roll, up to 60 readings per test, because you can set it to record every 10 seconds. You have a section for technician notes that you've never had before, so you can actually explain what happened at a service call, what the customer wanted, what they didn't want, notes for the next technician or notes for the customer to see, so you've never had that before. You have the ability to create an equipment database and a customer database. So you can have a customer that has 10 locations. You can have all their models and serial numbers tagged per location and have the reporting done accordingly. We also have customer sections for both technician, signature sections for both technician and for customer. So, and also too the customization, this is one was done for Cleaver Brooks, customization to actually have your company logo here. So if you're a contractor, you can now meet your customer where they're at. You can now produce for them or furnish for them a professional report that has your company logo, that has all the data. You can actually pinpoint certain data points you want them to focus on in your description, in your notes section, and you can help to put the story together along with the efficiency. So this makes it significantly easier for you to recommend the appropriate repair or the replacement of a piece of equipment because you have all this data backing you up and you can explain and dissect what each parts of these mean so that everybody can understand it. And these are some of the pictures. Again, these are just example of the 4 pictures we can have in, a couple of rooftops here. And you can also, like I said, the notes. And the way that it goes from a 3-page report to a 10-page report just depends on how many readings you want to capture. And we can also map different parameters. With the app that we have that's run either through your cell phone or through your tablet, full remote connectivity, you can have full coverage or full control over the analyzer from your phone or tablet. The only things you can't do, essentially, is the cracked heat exchanger test, gas pressure, and a few other things because we need you at the appliance using it, not off over here on the app. We want you at the appliance using it, interacting with the appliance, turning it on and off while the analyzer is mounted. But 98% of all the functions on the analyzer can actually be done through the app. Pause the pump, turn it on and off with the actual app itself. Change fuel type by a simple tap of the screen. Very, very simple, very easy to connect. And we'll have some footage on that towards the end of the presentation here. But this is what the mapping of the parameters that we can do. So you could take 2 different parameters, map them graphically, and see what the changes are in real time and the impact that you're making. We also have different accessories here. We have wireless printers, different probes, differential pressure hose kits. We have a flexible probe, which we'll have an image from or a video of at the end of this presentation as well for you to see. So we have different probes that you can get, so it's much more customizable than just a basic kit. So what is the difference with us, with the summary of features here? So with Combustion, what everybody's been used to has been a 2-year oxygen sensor. And that's been one of the Achilles heels of the industry. We now give you a 5-year oxygen sensor. Another Achilles heel has been the 2 to 3 or roughly 2 years CO sensor life, carbon monoxide sensor life. We now give you a 4 to 5 CO sensor life and a 4 to 5 NOx sensor life. Not only that, but you had no way of knowing with any analyzer when your sensor was going to fail. You had no idea how much sensor life you had left. All you could do was click a button and see if it's working or it's not. So it could be working today. You then drive 2-3 hours to your job site tomorrow. You go to do the auto zero and you get an auto zero error because your oxygen sensor failed or your CO sensor failed when you went to go test. That's been eliminated because we give you a sensor life indicator. So for every sensor in the chassis of your analyzer, you have a sensor life indicator. So you see exactly how much sensor life you have left with that estimated life indicator. And if a sensor is going to hit its end of life, we have an indicator for that. We will actually show up on your screen. Time to replace CO, time to replace O2, time to replace NOx, whatever that sensor is, we have an end of life indicator that will show up. And that will show up with enough notice for you to either send it in for service, or if it's a field replaceable pre-calibrated scenario, for you to order a sensor from us and change it yourself. So just to keep that in mind. So we've addressed the sensor life issue that has been plaguing the industry for a number of years. Again, going back down to what I mentioned before. For the CO sensor life, we have the programmable pump cutoff across all the models. So whether you get the 030, which is more of your residential like commercial, or the 130 or the 230, every model has that programmable pump cutoff and the 8,000 ppm threshold for it. And the 230 model has the advent of the additional feature of the 50,000 ppm protection. Colored touchscreen in the 130 and the 230, very, very useful. All three analyzers, all three, the 030 and the 130 are on the measureQuick platform. So the 030 and the 130 are on the measureQuick platform. We have the reporting enhancement that we've talked about earlier. So we have the longer reporting and the much more comprehensive reporting. All of these are BPI 1200 certified. So if you're in the BPI space, any analyzer you purchase from us can be used in that space. And you have the ability to add sensors to an analyzer after the fact. So if you got the 030 and you wanted to add NOx to it after the fact, a year or two down the line, send it in. We'll add the sensor in for the fee and the sensor fee, and we will recalibrate it and issue you a brand new model number because it becomes a brand new, a new model number at that point in time. Or if you want to add NOx or low NOx to this one after the fact, you can do that. So you can do that either at time of order or after the fact as your usage pattern changes or what you have to account for your customer changes, because we're all leading in the direction of accounting for NOx as we go through this, okay? And then we have the ability to set up to 5 different parameters. So when you're setting up a system, you could set a parameter alarm. So as you hit each one of those parameters, a visual alarm will go off to let you know that you've hit it. So it's like having eyes in the back of your head helping you as you set things up. And when we started off talking about combustion, myself and the other trainers that are around some years back, and some of the other ones many years ago, it was about talking about O2, CO, and CO2 and some other features. Well, now the narrative is changing a little bit. With everything going electric and having to account for efficiency, we thought combustion would be less important. It's actually more important now than it ever used to be, because now everybody wants us to account for efficiency, which we can now do. And we're trying to wring out as much efficiency out of a system as we can. And the only way that you're able to wring out the maximum amount of efficiency is for you to actually use an analyzer, dial that system in, commission it correctly, maintain it correctly, and diagnose it correctly. By doing those different things, that is the only way that you're going to ensure that you get the maximum amount of efficiency, safety, and longevity out of that piece of equipment. We have a YouTube channel. Here's the YouTube address right here for Sauermann Americas. We have videos on there. Craig is also going to have this video on his channel. We will also have it on ours. But we do have a YouTube channel that has other presentations on it and some other features of our analyzers and how to use them. And if you have any questions, please feel free to send those over through us in the comment section, or even send those to me in my email address, which you have on my credential slide here. So my email address is right there. Please feel free to send that to me. And I appreciate you sitting through the length of this presentation. Hopefully, by the time we got to this point, we build to the crescendo that I mentioned that we would build to, and that you actually learn more about combustion than maybe before you sat down. I thank you very much for your time. I appreciate what you do for the industry. I wish you all the best of luck in your future endeavors. And please contact us at SauermannGroup.com. We'd be happy to assist you in your training needs and also your analyzer needs going forward. And All the best to you. Take care.